Hi everybody, thank you for joining. This video is about significance and p-values, and it's about A/B testing. So if you've ever run an A/B test, you're going to get data back. It's going to be either significant or insignificant. Those numbers are based off of a slightly arbitrary but should be standard value that you get. A p-value is another way of describing statistical significance. So we're going to talk about what do those mean, what to do with the data, and how to use it. So I think it's really important because if you're a product manager putting a bunch of different experiences in front of customers and testing them, you've got one shot to figure out if it worked or not, and that's your A/B test. Now you're going to get back some data. Each metric that you collect is going to either be significant or it's going to be insignificant. The difference is huge. If it's significant, you can use that data, and if it's insignificant data, then you can't use it. So we're going to talk about what the two of those things even mean. Significance. It's a level of confidence that the data we collected represents a confirmed hypothesis or not. So this is level of confidence, not proof. Insignificant data means there's a high probability that the data we collected is noise. So notice I didn't say proof. Now, when we say significant, we're talking about statistically significant, which is an arbitrary threshold that teams will set to say if you've reached this level of significance, then you can trust that data. And when you use p-values, it's basically a different way of talking about significance. So when we say something is 99% significant, we're saying that there's a p-value of 0.01. 99.9% significant means a p-value of 0.001. Now, we're not at the Large Hadron Collider. We're not looking for the God particle. But if we were, our statistical threshold would be much, much higher. They use something like 99.99999% significance. And only then can they say that the data is usable. Now we're talking about e-com, we're talking about online retail. Typically those numbers are like 99.9 or 99% significance is the threshold we have to reach. Okay, so when we say significance, we say p-values, we're talking about the same thing. It's about a threshold we need to reach, and the p-value is just a more technical term used to describe significance. All right, so as I said before, significance doesn't prove anything. Now, this is the part that's had me re-recording this video 500 times. It's really important to understand that significance is not proof. When I say that something is 99% significant and 1% insignificant, I'm not saying that I have proof. I'm saying that there is a 99% chance that the piece of data that I'm presenting to you is true, that is a correct number. However, there's still a 1% chance that the number is total BS, that it's just noise. But because our threshold is so high, it's 99%, we're saying, look, that's a high enough threshold where most of the data is conforming at 99% so that we believe that number is correct. And there's only a 1% chance that it's not. Now you can set it anywhere you want, but like I said before, there are some pretty common thresholds that e-com and retail will use. There's typically three buckets. There's significant, there's directional, and there's insignificant. Now, significant is it's green, you can use it. I clearly marked directional and insignificant in red because that represents data you can't use. But there's some nuance, so I want to get into that. And not everybody uses directional, but some teams do. Significant, like I said before, means statistically significant, means we can use the data, so that's usually a 99% threshold we have to reach. Then there's directional. Directional can be a bit of a slippery slope because some people will quote it as gospel, and you should not because it's still insignificant, but it's saying, look, we're pretty close to significance. We think that we're headed down the right path. We just need to retest and get more data. Usually there's a 5% variance when we talk about directional data, so between 95 and 99%. Then there is insignificant, which is either below 99% if you're not using directional data, or say 95% below if you are using directional data. And insignificant means that there's just too much noise. We can't trust this number. So don't use it. Don't even attempt to use that data to prove anything because there's too high of a probability that what we're quoting is noise. So as we start down this process of understanding p-values, we need to set up a test. So let's state our hypotheses. That's the beginning part of any test. We've got a null hypothesis and we've got an alternative hypothesis. So say for the sake of this exercise, our null hypothesis, which is our control, is that gray buttons work great on our site. Then we have two alternative hypotheses. One is that the blue add to cart will convert better than our gray button. And then the second alternative hypothesis is that the green buttons are going to convert better. Okay, so we've got a control and two test variants. We're on our way. All right, so we get our data back. We've collected A/B test data. And as we see this graph, we're looking at the green buttons that have a 1.6% conversion, and those look pretty good. It looks like we should probably be deploying green buttons all over our site because they have a higher conversion. But let's wait and let's actually look at our p-values. And I'm not going to get into the math behind this, but it is pretty interesting. There are a lot of places where you can deep dive on this subject. All your p-value is that it starts with your standard normal distribution curve. And in a standard normal distribution curve, you have standard deviations, or your z-score. Okay, and you're comparing all of the data that you collected against your control. And so you'll start to see a curve forming in your data. When you have your z-score, you actually plug that into another formula that will spit out the p-value for that data. Your A/B testing tools are going to give this information to you. You don't need to run through and put this through your own formula. But what we've got is a p-value of 0.01 for our blue add to cart button and 0.20 for our green add to cart button. So now we need to interpret the data. So it looks like, given the buckets that we had, 99% significant 0.01 p-value is data that we can use. But the green 1.6% conversion has an 80% significance, and that does not meet our threshold, so we can't use that data. So what does that mean? It means that the winner is actually the blue button because it was statistically significant and it improved conversion over our control, and our green add to cart was inconclusive. So we can't use that at all. Okay, so there is a second part to this, which is how to use inconclusive data. And the big caveat before I talk about this is that really you shouldn't be using inconclusive data, period. But there are instances where it is helpful to understand some nuance, as with everything, right? So if you have enough data and you are convinced that the reason why you are not statistically significant doesn't have to do with the fact that you don't have enough data points, because that's usually the most common way to not get conclusive data. Usually the reason why you don't reach significance is you just don't have enough data, so you could never plot out on a bell curve your standard deviations because the data was all over the place. So say you have enough data, it just happens to be all over the place and there's no way to make sense of it. Sometimes people will say that's inconclusive and that's flat, meaning that customers didn't like or dislike, so it doesn't matter. Now, the only time you can use that is if there is no other data that is statistically significant, right? If you get an A/B test back and everything is inconclusive, then you could make a case that, look, we've collected enough data and customers essentially don't care. They're not making a choice either way, because maybe conversion is 0.01 for some customers, it's 10% for other customers, but there's no homogeneity to the data, in which case it's flat. Now, again, I would be really careful about saying that data is flat simply because it's not usable. So if you ever default to anything, default to your significant data, go after your significant data. If you don't know how to get it, make sure that you've run the test for long enough, make sure that you have enough data points, and then trust that significant data, because that's your, like I said, that's your one shot to know what customers want. All right, so that concludes this video about significance and p-values. I hope you could make heads or tails of it. It's a lot of fun to dive into this, and there's a lot of tools and reading out there if you want to get deeper into the subject and understand some of the math behind statistical significance.